Right, so this is lecture 6. So there's only actually 4 more lectures left, and then it's the end of term and Christmas, which is good. So this lecture is called Matrices and Conditional Execution of Code. Oh, so I'm going to focus on conditional execution of code today. Oh, you're all ill. Yeah, I haven't got it yet. I will soon, though. So I'm going to look at conditional execution of code and matrices. Now, the main topic of today's lecture is conditional execution of code. I can hear quite a lot of chatting. Just please, if you just don't chat to each other, it'll help me immensely. And then we're going to cover matrices, but in a very, very short, quick way. So here's an overview of today's lecture. Firstly, we're going to recap last lecture. Then we're going to look at matrices in MATLAB. And although you don't actually know it yet, you can actually do matrices in MATLAB. In fact, you know everything about matrices already. How many weeks have you been doing matrices in maths now? 4? You've been doing them since the beginning of term, right? Sorry? You finished matrices, right? Brilliant. So you know about matrices from a mathematics point of view. And I'm going to teach you how to do them in MATLAB in a really concise, efficient way. And you'll find it very useful. And then we're going to look at conditional execution of code, if statements and nested if statements, and summary. So until last week, you could only do linear programs. And linear programs look like this. They basically run from the beginning all the way through until they get to the end. And if you wanted to print out the word hello 100 times, this is how you'd go about and do it. You just copy and paste hello, 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 and the computer would say hello 100 times. Until last week, at which point we learned about the for loop and loops in general. And I said a much more compact and efficient way to do this is to use a for loop. And what this says here is it means for n equals 1 to 100. So what this will do is the computer will repeat everything between the for and the end. So in this case, it's the disp hello. And what it does, it counts up using n from 1 to 100. So the computer goes n equals 1, n equals 2, n equals 3, 4, 5, 6, 7, 98, 99, 100, and then it'll stop. So the result of this code is it will print the word hello 100 times, and it's just the same as this code, but it's much more compact. And I said loops are great because they save you lots of work, and they're incredibly useful, especially when you're sort of waiting for an event, like waiting for the correct altitude to open a parachute. And I said for loops are great, but a much more powerful type of loop is the while loop. And the thing about the while loop is it gives you a lot more control than the for loop. So the thing about the while loop is you've got to take care of the incrementing of the variable. So here we've got t equals t plus 0.5. So what this loop will do is it will execute while this condition here is true. So t equals 0, while t is smaller than 10, this loop will run. So it will run for 0, 0.5, 0.1, 1, 0, 1.5, 2, 2.5, 3, etc. And you notice in the for loop, there's no sort of n equals n plus 1. The for loop takes care of that for you. But with the while loop, you've actually got to explicitly say it. And I said this is very useful sometimes, because sometimes you want to control exactly when the loop ends and break the loop. It's called loop breaking, and while loops are very handy. We then looked at nested loops. So here is an example of a nested loop. And in this case, I'm using the for command to make a nested loop. And the idea of nested loops is it's one loop inside another loop, a bit like this Russian doll. So what happens here is we execute the first loop. So x will be 1, then y equals 1, 2, 3, 4, 5. Then we go back round, x equals 2, y equals 1, 2, 3, 4, 5. And what this will do is this will generate x and y coordinates. So this is incredibly useful if you want to evaluate an equation over, say, an xy plane. And we looked at this example here of evaluating an equation over an xy plane. So what this would do is this would spit out the coordinates x1, y equals 1, x1, y equals 2, x1, y equals 3, x1, y equals 4, x1, y equals 5, etc., etc. And we evaluated this sort of wave equation in this harbour and made some nice animations with these nested loops. And it was all quite fun. And hopefully in the lab, you'll have had a go at nested loops. So, matrices in MATLAB. How are we doing? So Dr. Chu, or whoever it is that teaches you maths at the moment, says you can do, so this is what he claims, you can do adding matrices, subtracting matrices, determinants, and inverting matrices. Is this correct? Yeah? So what I'm going to do now is I'm going to fuse the knowledge you've learned about MATLAB over the last 4 weeks or 6 weeks with the knowledge you've learned about matrices over the last 6 weeks. I'm going to show you how to do matrices in MATLAB. And it's incredibly easy and incredibly powerful. And it means you will never, ever have to do... You do Gaussian elimination? Is that something he teaches you still? Yeah, never, ever have to do that ever again, once you know this, okay? So it's sort of... I always think that whatever Dr. Chu can teach you, I can teach you faster and better. And, yeah. And this is all about... I'm trying to show you that basically computers are all about making engineers' lives easy. That's the point of a computer, is to make your life easy so you can go home quicker or finish the problem quicker and move on to something more exciting. Guys, if you've got a question... Excuse me? If you've got a question, just ask me directly. Yeah? Thanks. Right. So, your maths tutor has told you about matrices. So, you can define an array, a matrix called marks, so 72, 40, 50, 80, 60, or you can define a 2D matrix, for example, like this, 9, 8, 7, 6, 5, 4, and you all recognise that. These are matrices. And I've been teaching you about something called arrays in MATLAB. And arrays look like this. So, you could define the array marks, 70, 40, 50, 80, 60 in MATLAB, or you could define the 2D array in MATLAB, remembering that these semicolons here basically mean new line. So it'd be like 987, 987, semicolon new line, 654, 654, semicolon 321. So you can do arrays in computing and matrices in MATLAB, or the other way around. Now, this is the news for you. Arrays are matrices, and matrices are arrays. They are the same thing. Computer scientists call matrices arrays, and mathematicians call arrays matrices. They're the same thing. There's no difference at all, okay, in MATLAB especially. And in fact, I didn't tell you this to start with because you didn't appreciate what a matrix was, but the word MATLAB was actually originally derived from the word matrix and laboratory, so mat, laboratory. So MATLAB specifically designed for handling matrices. In fact, that was the original idea of it when the people wrote it. They thought, oh, we need a program to handle matrices. So that's why they wrote MATLAB. So MATLAB is fantastic at matrices. So let's have a look at some matrix algebra in MATLAB. And this is going to speed up your life significantly. So in the next 10 minutes, I'm going to teach you how to do matrix multiplication, calculating the inverse of matrices, adding, subtracting matrices, calculating matrix determinants, and calculating the transpose. Now, you already know this. I'm just going to show you how to do it in MATLAB. Okay? So, for this, I need a pen. And to read. So, you already know, or I taught you in lecture 1, how to do basic mathematics in MATLAB. So you know the star is multiply, the slash is divide, the power is raised to power, the plus is adding, and the minus subtracting, and brackets work all the same. Well, the good news for you guys... The good news for you guys is that all these operators also work with matrices. So if you define a matrix, you can add them, subtract them, raise them to power. All these work with matrices. So I've already taught you how to do all these operations on matrices. So have a little in-depth look now. So imagine you wanted to multiply matrix X by matrix Y. You could do it like this if you hadn't been to this lecture. What you do, so this looks horribly complicated, you'd write matrix X there, you write matrix Y there, you then write matrix X against matrix Y, and then you do this sort of multiplication where you go 1 times 1, it's so long since I've done this, 2 times 2, 3 times 3, etc., etc., and you get this sort of matrix out of it. And then what you'd have to do is multiply, do all these multiples, add that, multiply that, add that, multiply that, and eventually you would come out with this resultant matrix here. Now, I'll tell you this. If I try and do that in my office, I promise somebody will come in and disturb me, or I'll lose concentration, or I have to do something else. And I promise you, I will make a mistake if I try and do that. I will probably not do that correctly at the first go. Everybody's like that. We're humans. We get distracted. So this, I might be able to do that for this matrix because it's only, a 3 by 3 times a 3 by 2. But as soon as it gets to much bigger matrices, we haven't got hope. Okay, just as humans, because we're not accurate machines. So now you've got to play along with this bit. If you wanted to multiply 7 by 3, is that any good? 7, oh my goodness. That's a bit better. 7 by 3, what would you write? 7 what 3? Multiply. Star, right? If you wanted to write x in MATLAB, time is the variable y, what would you write? Star. So can you guess what you do to multiply the matrix x by the matrix y? X star, right? Exactly. So this is how we do it. We go, define the matrix x. So I've just gone 1, 2, 3, 4, So I've literally just defined this as a matrix or an array, define the array y, literally go z equals x times y, bang, it's done it. Okay? Now you can do any multiplications you want. And of course, because it's computer, I said before, this will work with bigger matrices. So no matter what size matrix you throw at it, it'll very happily do it. So here's literally an array of random numbers, and another array of random numbers, and the computer will very happily multiply them together within seconds, and you get the answer. Okay, so you now do multiplication. Now let's look at calculating the inverse. So you did this in maths, right? You got to calculate determinants if you want to calculate the inverse of a matrix. You've got to calculate the determinant, you've got to write it like this, do some division, and, anybody recognise that? Yeah? Well, it's a lot of work. That's also a problem. And you also mess this up. And this is a lot of work for 2 by 2 matrices. And I think once you get to do bigger matrices, it's Gaussian elimination again, or is that right? Or rearranging, or something like that. Well, you're going to make mistakes if you try and do that all by hand. You can't do it. And in my research, I deal with very often matrices that are maybe, 5,000 elements by 5,000 elements. And I also need to do these operations, probably about 100 a second. There's no way you can do that by hand, so you must get the computer to do it. So, here's another silly game. So you can write, so let's do it here, you can write 1 over 7 like that. And in MATLAB, how would you write that? It'd be 7, what operator? Not star, if you want to go to the power up to the -1. Hat, then what? -1, right? So now if it was x, if you had x -1, what would you write? Hat, yeah? So, you can probably guess now how you do that with a matrix. So if the matrix is x, you just do it like this. So you go x, you define x, then y equals x, the -1, and you've got the answer. And again, this will work with matrices of any size. Adding, subtracting matrices, I'm not going to insult your intelligence by asking you to do this or doing this on the board, but you know about adding in mathematics, you just add each row, subtracting the same deal. Works exactly the same with MATLAB. So we've got array A, array B, adding them, subtracting them. I can hear a murmur. That people are just talking over me. It makes my life really difficult. So if you could try not to talk, it'd be fantastic. So now, calculate the matrix determinant. Now, matrix determinants are a real pain. And you often need them in maths and in engineering, and as you'll see later in your careers. But if you want to calculate the 2 by 2 determinant, you do it like this in mathematics. And 3 by 3 determinants are already a headache, because you need to multiply this A by then sort of this bit, then minus this B, minus this bit, plus this C, plus this bit, and then you multiply it all out and calculate the individual determinants, and it's just a lot of work. And again, you make errors, and this is only a 3 by 3, and this just isn't scalable to big problems with 5,000 by 5,000. So MATLAB comes along and makes your life much easier with a det command to calculate determinants. So all we need to do now, if we want to calculate a determinant of a matrix, is go define it and type det A, and it gives us the answer. Easy. Works with a 3 by 3. Also works with a 9 by 9 with no effort at all. So as long as you can write the matrix, you can now do the mathematical operations on it in MATLAB. And I couldn't do that by hand at all. Right, calculate the matrix transpose. Do you guys know what transposes are in matrices? Do you? Yeah, you've done it, okay? So I don't need to repeat it. Well, I will repeat it just really quickly. So matrix transpose are actually quite handy in computing for sort of rearranging arrays. So in mathematics, the matrix transpose, you basically swap the columns and the rows, for those of you who can't remember. So I've done it in color scheme here. So the transpose of this matrix, so I've done the first row in red, the second row in green, and the third row in blue. You literally just swap the rows and the columns. So you write the red numbers like that, the green numbers like that, the blue numbers like that. So if we wanted to get MATLAB to do it, we literally use this single quote command. So what we do is we just define the matrix, go B equals A single quote, and it's done it for us. Easy. So we've done, matrices. That's it. You can now do matrices in MATLAB. There is no more to know, really. So, yeah, you can check your maths coursework. You can check your future coursework with this. you know, this is a really powerful tool for you to use throughout your careers now. So, yes, as I said, I've given you a little toolbox here of things you can do with matrices. So you've not actually learnt anything new. I've just told you how to do it. So you could multiply before, you could do inverses, you could add, you could subtract. The only new things I've taught you in the last 10 minutes is this det command for determinant, that's not difficult to remember, and this single quote, which is a transpose. So those are only two new things, and you've got this sort of fantastical toolbox now of mathematical tools. I think that's it. Are there any questions on that? Any burning questions about mathematics with matrices in MATLAB? Nope? Yeah, go for it. Just the same. Oh, I didn't show you division. You're absolutely right. Yeah, so you literally use, I've skipped division. Good question. Somebody's awake. You literally use that. Problem solved. Yep. Good. I like questions, by the way. Please do ask questions, because if you're thinking it, somebody else is probably thinking it too. Where are we? Right, so conditional execution of code. So this is a very important topic. This is like one of the backbones of computing. This is something that computer scientists, engineers do every day, day in out, conditional execution of code. And we're going to try and cover it in the next sort of 30 minutes. Yeah, 30 minutes. So I've slightly corrupted the English language in some of these statements, but never mind about that. So think about the following sentences. If the car crashes, inflate the airbag. If a fire is detected in the engine, turn off the fuel. If the aircraft is on a collision course with the ground, sound an alarm. So all these are called if statements. They all start with an if. It's like if something happens, do something. Okay? And this only do something if something is true. Now these are all the statements that give, if statements are the statements that give your computers intelligence. Okay? So whenever a computer decides something, like whether to take a measurement or whenever a computer makes a decision, it uses an if statement. So we've already met if statements before. So we had this rocket, this space capsule descending into the sea. And the program went like this, so this pseudocode. Am I going slow enough to open the parachute? If answer equals yes, open parachute. If answer equals no, do nothing. Line 4, go back to line 1. So here we've got two sort of decision statements. If something happens, then do something. If something else doesn't happen, do something. So if answer equals yes, if answer equals no, open the parachute, do nothing. These are if statements. So this whole rest of the lecture is about if statements in MATLAB. So here's another example of an if statement that we've already met. So answer, has the car hit an object? If answer equals yes, open the airbag. If answer equals no, do nothing, go back to line 1. So these are decision-making statements. Now, if these are wrong, you could have quite a serious accident in your car. If you mess these if statements up, the airbag could inflate while you're going down the motorway, and then you crash and die. So these are, always quite, well, it's true. These are quite important statements to get right. So, with that in mind, I'd like an interactive show of hands. So, how important do you think your ability to program if statements is? So how important do you think if statements are? Do you think they're not important? So hands up who thinks if statements are not important. Who's going to be brave? Nobody, okay. Who thinks if statements are quite important? Hands up. 1. Excellent, thank you. Who thinks they're very important? Okay. Now, this is the final option. Who thinks this could be the most important lecture you're ever going to have in your whole lives? And if you come to no other lecture, this is the lecture that you must attend. Okay, you're all right. I'm going to try and convince the rest of you in this next hour or so that D is the correct answer, okay? So, now, you can tell this is going to end badly already, because if you look at this slide, even with blurry eyes, you can see I've told you a price which is very big. So whenever I tell you there's a price that's huge, you know something bad's going to happen to it, okay? So here, we've got the cluster satellite, and I think this was sent into orbit by NASA and the European Space Agency to measure the Earth's magnetic field. And it was put on top of this thing. This thing is called an Ariane 5 rocket. And this is no firework. This thing is an absolute monster. Like, that, a man would probably come up to there on it. This thing is vast, okay? Now, An engineer made a single mistake in a single if statement on the guidance system of this rocket. Would you like to see what happens? Yeah? So this is why you need to get if statements right. Okay, ready? Okay, let's go.
Attention pour décompte final.
A final decision to go was taken.
10, 9,
So this is a huge rocket.
7, 6, 5, 4, 3, 2, unité, feu. Allumage. Décollage.
Keep your eye on the rocket, keep watching the rocket. Just watch the rocket's trajectory. Keep your eye on it very carefully, what happens. Looking good so far. Looking very good so far. Unfortunately,
Tous les paramètres propulsifs sont normaux, la trajectoire est normale.
that's quite
37
expensive.
seconds into the launch, the onboard computers decided 501 was 90 degrees off course.
Was it off course? No. Now, this, yes. This is possibly the most important lesson you'll have in engineering in your whole degree course, because you never ever want your face to look like that, okay? You never want to be on a team when somebody's made a mistake in an if statement, because it goes wrong. It's bad. So let's carry on.
They made an automatic adjustment to the trajectory as the rocket was traveling at the speed of sound.
I'll explain what happened in a minute. They also look unhappy. Yeah, right. So, yes. So I'll explain what happened now. What happened, so this is basically a summary of what happened, so it's a really condensed summary. Now if you want to read exactly what happened, you can actually go to Wikipedia here, and you can actually look at the code that was wrong, and they've actually got a code snippet that was wrong, and a code snippet of what it should have been. Now, so in a very quick summary, what happens is sometimes, so accelerometers measure basically the position of the rocket, and it tells you whether it's vertical and which direction it's going in. And sometimes these give unrealistic values, okay? Now, what you need to do when a sensor gives you an unrealistic value is chuck that value out and say, oh, it's unrealistic. You know, it's like faster than the speed of light. You know, this can't possibly be true. Just chuck the value out. So what the engineer should have done is put in a statement that said basically, if acceleration is bigger than this value, ignore the value, okay? And he forgot to do this. And because he forgot to do this, the computers then thought, oh, I'm 90 degrees off course. I must correct my trajectory. And it wasn't at all 90 degrees off course. And when the rocket tipped over like that, because it thought it was correcting itself, then sort of the supersonic airflow just destroyed it. So this was all caused by this one if statement. So that's quite a good example. Would you like to see another? Yeah? Okay. Oh, right, no. Before I show you the next one, I want to tell you about aircraft. So if you fly an Airbus, the pilot's controls, so his control column and the throttle, aren't connected to the engine, okay? They're only connected to a computer. So basically when the pilot says turn left, that's merely a suggestion to the computer that he would maybe like the aircraft to turn left at some point in the future. It doesn't actually turn it left like in a car. And the same with the throttle. The throttle is only connected to the computer. So the pilot puts the throttle up, and then the computer thinks about whether or not it should actually increase fuel to the engine. So there's this disconnect between what the pilot's telling the aircraft to do and what the hardware is actually doing. So for example, if you have this statement, if new position of throttle is bigger than old position of throttle, increase fuel flow, then the computer would sort of decide whether or not it wants to increase the fuel flow to the engine. So having said that, let's watch this video. Now, what I'm about to say is sort of oversimplification again, just to get the message across in a very short amount of time. But what's happening is, I think this was at Paris, and this is sort of a maiden flight or very early flight of this A320, and it's full of passengers. And the idea was basically to just go and visit this air show, just touch the runway and take off, and then go on holiday. However, so it's full of passengers. Remember that. What happens is he's doing his flyby now, going past the camera, and now what the pilot does is he pushes the throttle lever up to increase fuel going to the engines. However, the computer decides it doesn't want to do that. The computer says no more fuel to the engines, and it's not finished yet. Yeah. So computers kill people regularly. In fact, nobody died in that, I think. So in fact, they all walked out. I think that was just the wing tanks exploding. So I found this, just to hammer the point home, I found this from The Guardian, and this was about, that was like 1996. So this is 2015. So Airbus has recalled these A400M aircraft, the big military lift aircraft, because the computer basically drove it into the ground and killed everybody on board. So the point is, if statements make decisions, and computers regularly kill people because engineers regularly get if statements wrong. Okay? So, on that cheery note, what we're going to do is practice if statements. Right. So who thinks if statements are important now? Yeah? Yeah, more than last time. Okay. Right. So, now let's do some if statements in MATLAB. So, here is the most simple if statement that I can think of. So this is, you can imagine this type of decision-making thing happening in your car or in your GPS system. And it's telling you whether or not you're going so fast. So this is how it works. Let's first define a variable called speed. And we've got speed equals 80. And here is an if block. So if statements start with an if and end with an end. Okay? So if this statement is true, then all this code between the if and the end will be executed. If this statement is not true, then all this code will not be executed. So, speed equals 80. If speed is bigger than 70, display too fast, slow down. So this code will only be executed if speed is bigger than 80. So now let's have a play with that in MATLAB. Okay, so here we are. Here's our program. So let's just see what happens. Okay, there's our output. So let's just run it. So speed is 80, so too fast, slow down. So let's change the speed to 40. What will happen now? It'll print out nothing, right? Run it, doesn't print out anything. Change the speed to 100, what will happen? Too fast, yeah? Run it. Now, this is a trick. What will happen now? Think about it in your head. You don't have to shout it out, just think about it. I'll give you 30 seconds to think about it. So, the test is if, so speed is 70, so if 70 is bigger than 70, is 70 bigger than 70? No. So what will happen is 70 isn't bigger than 70, so it won't print anything out. So this is one of those corner cases that often catches people out. When you compare two numbers, sometimes people expect, to print out you're going too fast at 70. And this is one of those things that often makes programs go wrong. Okay, I think we've had enough of that. So, boom. Right, so we actually met this comparison before when we were doing while loops, and I gave you like a list of comparison operations. And I showed you this list, and I said bigger than, less than or equal to, greater or equal to, equal to. Now, the thing that always catches people out with these if statements is this equal to. Always, people write, is a 1 equal 1. You must always write when you're comparing, is variable equals equals. So when you want to compare two variables, you must always put a double equals, or not equal to. So, very often in life, you have to make decisions. So, obviously I'm going to corrupt the English language here again, just to get the point across. But if I have a coursework deadline, go to the library. Else, go to the party. If I have £50,000, buy a Ferrari. Else, buy a used Fiat Punto. These are, or a VW. These are all examples of if-else statements, and you will meet these all the time in programs. So here is an example of a if-else statement in MATLAB. So we've got a variable called money. Now, if money is bigger than £50,000, it's going to go disp, buy a Ferrari. Else, so if this condition is not met, buy a Fiat Punto. End. Okay? So it'll only print buy a Ferrari if you've got more than £50,000 in the bank. So we've already made like an investment manager with a MATLAB. So let's have a look at this. Right. So here we go. We've got our buy a Ferrari or buy a Fiat Punto. So we've got £5 million in the bank. So when we click it, what are we going to buy? Ferrari, right? Buy a Ferrari. Now we've got £10 in the bank. What are we going to buy? Fiat Punto, right? Buy a Fiat Punto. What, £1,000 in the bank? What are we going to buy? Fiat Punto. 60,000, Ferrari. Right, so the point is, this computer code is executing, or the computer is executing either this statement or this statement, depending on whether this condition is true or false. So you can start to build up now some quite complex sort of logic statements that we'll get to in a minute. So you can also sort of stack these statements. So you can say, if something's true, do this. If that's not the case, check if something else is true, do this. And then if none of those conditions are met, do something else. So this is called an if-else. So if-else statement. So it's very simple. So here we've got speed equals 60. So basically, imagine we're trying to write some code to tell you how fast to drive your car on the motorway. So here's speed equals 60. If speed is bigger than 70, disp too fast. Else if, this means like, if the first condition is not met, try this. Else if speed is slower than 30, disp too slow. Else, speed okay. So if you're going bigger than 70, too fast, less than 30, too slow, and everything else is okay. Any questions so far? No? It's all pretty simple stuff. Yeah, so we can stack as many of these as we want. We can combine greater than, smaller than, equal to. So here we've got if speed is bigger than 70, too fast. Else if speed is smaller than 30, too slow. Else if, here's this double equals coming up. Speed, and this is always a trap. Now, I'll say this because in MATLAB, it might warn you if you put a single equals. But in many languages, it won't warn you if you don't put a double equals there. It'll just assume you want a single equals. And a single equals means set the value on the left equal to the value on the right. So what would happen in a language like C, for example, is this, if you had a single equals there, it would set speed to 65. And then you might have horrible consequences. So always always put double equals when you want to do a comparison in a program. Then else speed equals okay. Okay, so this is called if, else statement. Any questions so far? No? It's all pretty obvious. Right. Now, imagine you're programming one of those self-checkout things in Tesco's, and it's your job to write this program. If the variable weight is smaller than 1, you've got to print the words no muffin. If the weight equals 15, you've got to print the word 1 muffin. And if the weight equals 35, you've got to print 2 muffins. And if none of the above conditions are met, you've got to print muffin error. So, I would like you to scribble on the back of your notes an if-else statement that basically does this. So it's your chance now to do some actual programming. And to speed you all up, I've actually got something that resembles a muffin for the first few people that do it. So there's actually in the notes an example of last year's answer. It's not the same as this one. Is it that bad? Was it fireworks night last night? Oh, that's looking good. That's looking promising. Almost there, yeah? So don't try and guess the syntax. just look at it in the notes, because I've basically given you the answer already. I just want to try and make it go into your memory a bit. How are we doing here? Yeah, looking good. You got the answer? That's super quick. If, yes, you fell into the trap. Yeah? You want to be the first one? That's all right. Anybody else got the right answer? It's the first time we've been silent today. Who's got, hand up over there. Okay, I'll come over there. Where's the hands? Let's see. Let's see. Very good, yes, there you go. Anybody else got the right answer? Hand over there. Oh, you're closer. Let's see. Good stuff. Brackets around there. You got to put brackets around there. Round the if, yeah? Yeah? Go on, have one. You're close enough to have a muffin. Hand up over there. Oh, I saw you. There's enough for you, both of you. Looking good, yeah? Some people are using capitals. Don't use capitals in if-else statements because the computers are case sensitive. There we go. How are we doing? No disk commands. Let me see. Yes, looking good. Take one of those. I've got to hurry up because people are. Yes, let's look at that. Yep, take some of them. Show me your answers. Yep. Let's see yours. Yep. I'll give them one. Don't take the box. There's only limited muffin supply. Who else has got them? Yeah, looking good. Oh, you got you got to put brackets around the disk. Sorry. What are we doing here? Yeah, good. Have some of those. Right. Okay. So that's the end of the muffins. You've got to share them out equitably now. Go on, give them to people who got the right answer. So, how are we doing? We've got about 5 minutes left. Yeah, we've got about 5 minutes left. So, I think you all got the idea of that. Now, the thing is, these if statements, as I say, are deceptively easy, but do kill people. Because if you make the wrong logical choice, that's the end, literally. Okay, so this should have been the right answer, or something that looks like this. I'll put this on Moodle later. So it's basically, if it's more than 1, no muffin. So here I've got weight equals 80. If weight is smaller than 1, no muffin. If weight is equal to 15, 1 muffin. If weight equals 35, 2 muffins, else muffin error. So you should have had something a bit like that. And if not, there's worksheets today to work on if-else statements. Any questions about this so far? Stick your hand up if you've got any burning questions. Okay. Guys, I can't talk over you. I can't talk over you. Thank you. I can't talk. Yeah, okay, whatever. Right. So, nested if statements. Now you can basically combine if statements into so you have like one big if statement, then another if statement, then another if statement, another if statement. So you have one thing executing if one condition is true. So, for example, imagine we're writing the code now to decide whether or not to open the parachute on this space capsule. We could have one if statement here that said if speed is smaller than 200, and then if altitude is smaller than 20, open parachute. So it'll only enter this if block if the speed is smaller than 200, and it'll only enter this if block if the altitude is smaller than 20. So you've sort of got it's like doubly gated, so it'll do only this thing when both these conditions are met. So let's have a little play with that with the video. So here we go. So we've got speed equals 1,000, altitude equals 100. Will it open the parachute? No, right? Because speed is bigger than 200 for the start. So let's change altitude to 50. Still won't open it. Still won't open it. So So this condition, so now altitude is basically 1 or 10. So this condition would execute, but it's not even allowed to get there because it's still stuck. It's still not allowed to execute this code because this condition hasn't been met. So now, only when so this is now true, but only when we set, so speed is 500, no, it won't get down here. Speed is 250, no. Speed is 20. Now it'll open the parachute. So only when both this condition has been met and this condition has been met will it execute this code inside this double if statement. So you can build up very, very complex if block statements like this. And the warning is, the more complex the code you build up with these if statements, the more nested these if statements are, basically, the more danger there is of making an error. So try and avoid nesting it too deep, but you know, this is quite a nice example. So, whoops. So, now, whoops. Now, this isn't in the end of the lecture because I'd like to go over the coursework. So today, we have covered, recap of last lecture, matrices, conditional execution of code, if statements, nested if statements, and summary. Now, I'd like to talk to you about the second coursework now, because we've got a bit of time. I was going to do this at the end, but you didn't have it. So, the first coursework, has everybody handed in the first coursework already? Yeah, most people. So I think you've got another 2 days left. Now, last lecture, I decided to give out the second coursework because people had requested it. For people who are going fast. But today's the official giving out day of the second coursework. Now, the first coursework you did, the difficulty level was basically flat. Like everything was about equally difficult, and it wasn't very challenging. Now, because we've got a mixed ability class, we've got some people who are sort of love computing and some people that don't like computing, I've made this coursework sort of the difficulty level increase. So if you notice at the beginning of the coursework, basically, I'm throwing away marks. I'm literally giving you marks. So like question 1, you can get 5% for just copying something out the notes, okay? And then question 2, you know, a few lines of code, you get another 10%. And it continues like this. So you very easily accumulate marks in the first section of the coursework. And generally, I expect everybody to get about 70 to 80% on the first coursework and about 60% on this coursework because it's more difficult. And basically, it continues like that until we get to question, where are we? Until we get to question 6. So question 6 is quite difficult. I'm going to say this. It is quite difficult. Not everybody does it, but it's only worth 20% of this coursework, okay? So it's like there to challenge the people who want to challenge. So have a crack at it. We'll give you some marks if you have a go at it, but if you don't finish it, don't worry. And the final question, which is question 8, is like a bonus question for 2%, okay? So this is very difficult. So if you love MATLAB programming, you can gain your last 2% by doing this. But basically, the difficulty level's staggered, so there's something for everybody. And don't worry if you don't get to the end. Just do your best, and we're there in the labs to help you. Any questions, we'll answer them. And the other reason for doing this is that if I only set you sort of very easy tasks, then you won't really learn. So it's sort of the idea is to sort of gently ramp up your basically your knowledge and your ability with MATLAB. So it's sort of this one's a little harder than the last one, but don't worry about it. And we're here to help, and we're all here to learn it together. Any questions? No. So off the labs. Oh yeah. Deadline December. I'll put it on Moodle. I'll put it on Moodle.